Forgot to start the video. That's okay. It is. So we said, this is just for the video purposes, guys. You can ignore me here. We said that we went up 50 over 25. So our slope would be 50 over 25. That's Presley in the background laughing. So that reduces down to 2 over 1. And then we said that because our new path is perpendicular to the recreational trail, we know it's going to be hitting and making 90-degree angles. Well, if that's 2 over 1 and it's perpendicular, that'd be opposite reciprocal. Flip, change that to a negative, and so we go down 1, right 2, down 1, right 2. Okay, how about, let's go, Justin. Help me out, man. What would be the equation, slope-intercept form, of the new path we just created? Well, where'd the 100 come from? Yep. We know our new path is hitting the parking lot. Well, the parking lot is on our y-axis. It's sitting at 100 on the y-axis, so that's your y-intercept. That's your B. And we already found the slope in part B. Nice work, man. How about part D? This one maybe isn't a mid question because it's just about looking at a graph. But how about, say, it's actually not a bad throw. How about Bree? What's the coordinates where our new path is going to meet the recreational trail?
100.
Hey, just making sure we got the X and the Y right there. Bree's got it. Hundo and 50. Let's go. And then the last one. This is the tough one, guys. We know each grid is 25 by 25. What are they asking here, Taya, in part E?
How long is the path to the main road?
Ooh, now guys, how are we going to find that out? Take a look at our graph. How are we going to find out how long our new path is? It's a diagonal line, so we can't just like look horizontally or vertically here. Give you a second. I'm hoping it comes to somebody. It came to a few people in my 7th period. I was super proud of them. We can make something to help us. What did we? I'll call this D for distance. What are you thinking, Jack? I'm sorry. Why do you think they gave us that earlier? If each grid is 25 yards by 25 yards, you think maybe we could use the rest of this grid? How far vertically are we to get down from the parking lot to where it meets the trail? Wouldn't that be down 50? How far over would it be from the y-axis over to where we meet on the x-axis? Wouldn't that be 100? Wait a minute. What did we just make?
Right triangle.
Hey, and what theorem do we have that can help us find a hypotenuse of a right triangle? We got some Pythag here. Let's go. Yeah, anytime you need to find a diagonal line, use your vertical and horizontal axes, and you can use the Pythagorean theorem every time to find distance. Pythag can save your life. So if you don't remember, we got a squared plus b squared equals c squared, where c squared is your hypotenuse. Well, in this case, our distance is the hypotenuse. Well, no, that's what we have to find, my man. Aren't we trying to find the distance between the parking lot and where it hits the nature trail? What they give us is they give us the parts, A and B. You're good. So we got 50 squared plus 100 squared equals our distance squared. And I'm going to let you guys see if you can find that answer. Round it to the nearest whole number. So you don't have to worry about decimals. If you get a decimal and it's above 0.5, you round that sucker up. Let's go. Well, but then you take the square root of it. So, Jack, you good so far, man? We square each, add them together. And then how do you get rid of a square?
Is that the answer for about
Well, no, because what's still above the D there? So how can we get rid of a square? Ooh, not dividing by 2. I think Ethan said it.
Square root.
You can take the square root. Heck yeah. Yeah, if you ever need to get rid of a square root. Those two are opposite operations, like multiplication and division. A square and a square root. Yep. And you'll get a decimal. Round that to the nearest whole number. And we'll see what you guys are thinking. How about, Lucas, did you have a chance to get it? Fantastic. If you need one, I got one up here. How about David? Go ahead.
I don't know.
Fantastic. It's not like they don't have them on your phones, right?
Those ones don't work.
You turn it sideways.
Oh.
12, 5. I'm literally doing this right now. And then you take the square root. Oh, it's there. Hey, there we go. 111.8. Which rounds to what, Lucas? Would that round up or down? 0.8, right? So that'd be, you're good. That'd be 112 yards. Ooh, that one was a little bit tougher. If you struggle with part E, guys, that's okay. Hopefully that one was about the only one that was really maybe tripping us up on that section. What are some questions you guys have, though, before we jump into this short day 7? Any questions at all on that? Okay. Then, very, very briefly, just want to jump into day 7. It's got some recap mixed with a new form that you guys have probably not seen since last year. So I'm going to try and, like I said, keep it brief. But big thing is Dakota Female Edition. What is our topic going to be? So guys, I'm not going to go back through all of this table. We saw these formulas on Friday, and we saw them yesterday. What's the one new one in there, Jake, that we've not talked about yet, man? Yeah, standard form, yes, sir. And would you care to give us a quick recap? What does that look like, man? I like to call that the alphabet one. It's the only one where you got the ABC in there. And really, when we get into some Algebra 2 stuff, ABC, standard form, it's still going to stay the same. Even when we look at new standard forms, they still have that ABC mechanic. Now, let's see, Lily, what are some things we know about A, B, and C? That's a tough word. They're coefficients. That's right. A and B both can't be 0 because, Hunter, if A and B are both 0, what letters do you notice are attached to A and B? If A and B are 0, you don't have variables. And if you don't have variables, you don't have an equation. So A could be 0, B could be 0. They both can't be 0. How about, Hunter, what's something else A and B cannot be? That's right. Whenever we do a standard form, we like to write it out in a pure way where we can find intercepts. And the way we want to write that out is not having any fractions. So that's one good thing. You don't have to worry about fractions necessarily. How about a little throwback, though? You guys did a problem like this back on Friday. I want to see what we remember. So let me step aside for a second. I want you guys to look at this first problem. Take a second to read it. This is not about standard form. I want to see what you guys remember from Friday. We'll come back together here in about a minute, and we'll talk about this one. See if you can set this problem up, given what they've given us. Yes, so we've got 7 plus 1, because again, double negative. 7 minus negative 1. What's up? I do. I got to get used to it. No, this is being honest. So we got the slope formula is going to be this right here. We're plugging those values in. And guys, anytime you see a fraction equals a fraction, Chandler, what is your first thought? Anytime you see a fraction equals a fraction. Besides the panic. That's all right. How about somebody else here? What's your first thought when you see a fraction set equal to a fraction as far as to solve it? They really are division problems, but how do we undo division? We multiply. Guys, if you have a fraction equals a fraction, we can cross multiply here. Check it out. Multiply that together. And then, of course, we know 7 plus 1, that would be... So I'm going to go ahead and simplify that on my fraction. So, yeah, we can go ahead and cross, multiply, and this problem becomes a breeze once you do that. This goes from being unsolvable to, wait a minute, I'm just going to cross multiply. So, how about, Taya, what do we get 3 times 8? 24 equals, now guys, be careful here. If you have 4 times multiple things, what are we going to do with that 4? Well, there's a word I'm looking for. It rhymes with distribute. We're going to distribute.
It's not even a word.
Sure it is. It's Italian.
For what?
Pastrami. Yes. See, somebody else knew. 4 times V. Wait, pastrami, I guess, is Italian for pastrami.
Exactly.
Give me a second. I'll come up with some lie. So 4 times V is 4V. 4 times 5 is 20. And I'm going to let you guys take that the rest of the way.
Oh, that's easy.
Oh, yeah. We're on easy street now.
Oh, did you have an answer out loud? Oh.
He's got a flex that he knows the answer. How about, just kidding. How about, Jacob, what'd you get for V here? You? Yeah.
I'm not gonna answer that. I'm Florian.
Oh, I thought you were sworn to secrecy. Isabella, go ahead. Look at her, wanting to take us through. Yes, ma'am. So really, I know the setup for that problem is a little bit tricky, but if you see that you're dealing with slope, you can kind of set up that equation, and it's just about cross multiplying. Here's going to be the only new part for today, guys. Only new part for today. So, standard form. What did you guys notice about standard form? Jack, what makes standard form a little bit different?
So it's just, so, I really don't know.
Well, now wait a minute. What are A, B, and C? Aren't those just?
Those are slow.
Aren't A, B, and C just numbers?
What's coefficient?
Coefficient means the number next to a letter.
Oh, yeah.
So, Jack, what would you like A, B, and C to be? Let's do an example of standard form up here.
Okay. I want A to be 6.
That's my favorite number. So 6x plus,
9B.
well, okay, hilarious, equals, I'm amazed you didn't go 420. That was your chance and you blew it.
No.
You blew it.
No. 400.
Okay, great choice. So, that's an example of standard form. So that's an example of standard form. A and B are not fractions, or I'm sorry, A and B are not fractions. A and B are both not 0. But what do you notice? Press, what side is X on in this equation? Is it on the right side or the left side? Wait a minute. Hasn't it in the previous 2 formulas always been on the right side?
Yeah.
Yeah. So guys, with standard form, we bring the X over to the left side. That's the only difference. X and Y are on the same side. So look at number 1. Male form of Dakota. What form do you notice number 1's in right now? I don't know how to distinguish him. I guess his name.
What one do you call next to
Yeah, that's Y equals MX plus B, isn't it? So if you're in slope intercept, usually it's just one step. What's the only thing we need to move over?
The Y.
The X.
The X. The Y is in a good spot right now. It's on the left side. We need to get the X on the left side. I remember, Press, remember doing some of these last year?
Yeah, so the X becomes positive, isn't it?
Yeah, in order to move the X over, you have to do the opposite operation. Add 5X over. That cancels it out on the right. And then, of course, we want to move it out front. So we've got 5X plus Y, right? Because Y is still positive.
Heck yeah.
Is there anything else we need to do there?
No.
No, that's it. No fractions. A and B are not both zero. We're
What
good.
happens if you get fractured? Does it matter?
Well, we're about to look at one right now. Look at number 2. Hey, Jack, there's only one step we got to do, man, if we have a fraction. Okay, can we do kind of the same thing we did on number 1 here? Can we move that X over? Sure. So if it's a positive 1/2 X, how would you move it? Yes, ma'am. Subtract 1/2 X over. And here's where we're going to answer Jack's question. So if you have a fraction for A and B, really easy fix. Anybody remember how we can destroy a fraction every time?
Flip.
Not necessarily about flipping it. I heard somebody say multiply. Is that you? We can multiply by its what? Not even necessarily by its reciprocal.
By it.
What if you, I heard somebody say it, what if you had X over 3 equals 9? How would you get rid of that fraction?
3 times 3.
Oh, you multiply by the denominator. Well, guess what? You do the same thing here. If you have a fraction, multiply by its denominator. The problem is, Jack, what else do we have to multiply by that too?
That negative 1.
Well, you gotta multiply the whole thing.
shebang.
When you multiply or divide in an equation, you have to multiply or divide every single term. You can't just do the first term. You gotta keep this thing balanced. So you're really gonna distribute that too to all 3 pieces. And I'll give you guys a second to see what you get on that one. You're gonna distribute that too to all 3. And then after this, we're gonna stop. I'm gonna let you guys partner up, give you a little H dub, and then I'll give you guys the last 10 to 15 minutes to work on delta. So, final statement here for a minute. What did you guys get for number 2 after we distribute that 2? One more time, Isabella.
Negative X plus 2Y equals 18.
Let's go. Yes, that 2 cancels out with that 2, leaving you with negative 1. X, 2 times Y is 2Y, and 2 times 9 is 18. Great job. Excellent job, guys. So what I'm going to do now, we're going to flip over, and I'm going to let you guys partner up. And as you partner up, I just want to leave you with one final thing. Standard form. A lot of people are like, what's its use, right? We know slope-intercept form. Oh, that tells us where the line's hitting the y-axis. It tells us what our slope is. Point-slope form tells us what a point is on this line. It tells us what the slope is. What does standard form help us with? What good is it?
Standard equation.
Well, not necessarily with knowing standard equations. It actually can help you with, check that out up there. Bree, what can it help us find? And so, guys, before you partner up, when I say it's good for helping us find x and y intercepts, give me a quick reminder. You guys are my geometry class. What is an x-intercept? If I were to tell you, like, if you're looking at a graph, what is an x-intercept?
When the line crosses over the x-axis.
It's when the line crosses over the x-axis. Doesn't that happen at a point? Yeah, that happens at a point. And what do we know about a point that's on the x-axis? Ethan, if you're on the x-axis, what will y always be? If you have a point on the x-axis, what will the y-coordinate of it always be? Like if I'm right here, What would you say the coordinates for that point right there are?
0.
Wouldn't it be 2, 0? So Ethan, if you're looking at an x-intercept, y will always be 0. How about if you're looking at a y-intercept? Same thing, except now what will be 0? X is going to be 0. And so look at how this helps us. So we know with the y-intercept, that's when the x is going to be 0. Check it out. We have an equation set up with x and y both on the same side. Lily, if we know that to find an x-intercept, we know y is going to be 0, then to find this x-intercept, couldn't you just say, hey, let's plug 0 in for y and find out what x is? Could you do the same thing to find the y-intercept? Yeah, to find the y-intercept, hey, let's just plug in 0 for x. So negative 4x minus 2 times 0 equals negative 8. And negative 4 times 0 minus 2y equals negative 8. Check that out. We said, okay, in standard form, I can just plug into 0 for the y to find the x-intercept and into the x to find the y-intercept. And I'm going to let you guys see if you can take it the rest of the way. Once you find out what our two intercepts are, you're going to graph those intercepts. You're going to use that to make your line. And then we just got some questions at the end to help you out. Yeah. So you're going to partner up, and I'm going to let you guys work. Take the next 5 minutes to work on this page right here. So HW is going to be page number 3. Yep. So 3, 4, and 5. Again, we see here that B could be anything but 1, because otherwise it'd be the exact same line. It has to be the same slope. Number 2, A and B have to be the same. C's got to be different. All right. So HW is page 3. And if you want to see if you got these right, I'll put them up here for you. Yep. So if you want to double check, guys, here are those last 3. And don't forget, page 3 is homework. Also, I've already put out the reviews. I've already got that material out to you guys. So if you want to go ahead and be working through your review for our test on Thursday, you're more than welcome to. We're going to review tomorrow, but I just wanted to give you guys a chance to get a head start if you needed to. Those are already available. So negative 2 over 3, what's the opposite reciprocal, say, of negative 2 over 3? Positive 3 over 2. Cody, how about what's the opposite reciprocal of 5? Yep. So that's what we're getting for these perpendicular slopes. And B can be any number.